So I'm going to take just 1 minute to invite you all to our Singularity user group, as we are here in the EasyBuild user group. We are going to be hosting a user group thanks to the San Diego Supercomputing Center next March. So call for paper is open. So if you have a really interesting use case or you are facing a challenge by using Singularity, please let us know in the call for papers, and we are welcoming users and contributors of Singularity. Super quick announcement. If you are interested, I know that the link is kind of hard to copy and paste, so reach me after this talk and I give you a better link to the conference. Okay. So I'm here to talk about Singularity. I kind of feel that everyone here is familiar with the tool and what Singularity is doing. So I'm going to do a super quick one-on-one with 2 slides, and then I'm going to give a big update on what Singularity this year and the new changes that are coming into the repo and all the new features that are in the upstream master right now. So for those not familiar with Singularity, it was invented by Greg Crutcher, the same founder of CentOS in the National Laboratories, some point around October of 2015, because users were knocking his door about using Docker on HPC facilities with root privileges. The field release came some point 1 year after that, and with a lot of user feedback and user contributions from a lot of universities and HPC centers, it really turned into the 2.0 release around middle 2016. And last year, Greg founded Sylabs, a company to back up the Singularity open source project. So by saying this, we started to work in a complete rewrite of the code to make it more professional, and so we can give a better support for users. And we released the 3.0 version in October the last year, and I'm here to talk to you about what this 3.0 release is giving to the users. So Singularity will never forget that it is designed for HPC and it was born on HPC, but it is getting a lot of features from this new world called the commercial enterprise, the cloud. But Singularity is optimized for compute jobs, supports all known resource managers. So Singularity was born by being run by Slurm, HT Condor, PBS. You name your resource manager, you can run it with Singularity. It is compatible with all HPC infrastructure. So I was just talking to a user that Singularity is being run in Cray systems with 20 years old, CentOS 2.1, 2.2 kernels. So every HPC system out there, Singularity can be run. So it is think to be running these all supported HPC systems. Users can bring their own environment into the HPC environment, which is what had really make Singularity thrive into a HPC culture, because HPC systems tend to be some kind of old, and users are running the new CentOS, the new Red Hat, the new Ubuntu on their workstations, and they want to take that environment into the HPC and just run their tools without having to accommodate their system, what they are developing, to the version that the system admin has on the HPC infrastructure. And one of the main concerns of all system admins is the security. So Singularity blocks all privilege escalation from the user. However, or whatever the way that container is being run. So it is being run through a scheduler, it's being run manually. However it's being run, Singularity will drop all privileges, really giving all the tools and all the power to the system admin on what he wants to give to the users. Singularity is also think simple versus how the cloud and all the new tools like Docker and OCI are really designed. Singularity, by starting point is just a single file image versus the layer format that all OCI compliant runtimes are using. And one of the main things that this gives us in the HPC realm is that you can share really easily your Singularity image to INFS. So you can just put your Singularity image in INFS, in a Lustre, or whatever your show file system is, and you can be run that same image through your whole HPC infrastructure without having to worry about how you are going to be moving the layers and how you are going to be linking the layers on every node depending on how you are sharing your resources through your HPC infrastructure. Also, Singularity is think as a binary. So after you build your container image, it is turned into a binary itself. So it is think like that, so it can be run through any scheduler rather than the OCI compliant runtimes, which they are trying to themselves schedule into the system. Singularity is just there to be run. It is not trying to run or be the master on the system. Singularity is just there to be run by a scheduler or by the system admin. So it is really simple. It is not trying to do really complicated things on the host or leaving a root daemon, trying to orchestrate containers in the host. No, Singularity is just there to be run. So it is really simple to use. So for those not familiar with Singularity, these are the main runtime features. As I told you, this was a super quick one-on-one. Singularity works out of the box with GPUs. So if you have a HPC infrastructure with GPU, NVIDIA, you can start running your machine learning, AI, or graphics integration with GPUs out of the box with Singularity images. It is standard compliant, so you can now run any Docker or OCI compliant image with Singularity, and you can now pull images from any OCI compliant registry and just start running it with Singularity. As long as it is a registry OCI compliant, you can pull it and run it with Singularity as a rootless container. Supports graphical user interfaces, and that combined with GPU. I don't know if you guys follow last supercomputing, on which the keynote from NVIDIA showed how you can ship a job with a Slurm, and with that job in a Slurm over a GPU cluster, run a graphical user interface and start doing some graphical analytics with Singularity containers. It is resource manager agnostic. As I'm saying, it is really simple. It is think to be run as a binary, so you can ship it with whatever resource manager you want. It is compatible with any HPC infrastructure, so Singularity can work with InfiniBand. Singularity can work with any share file system you have in your host, GPUs, all HPC tools, hardware tools out there. Jobs and services. Singularity at first was designed to be a batch job, but on request of the users, Singularity can now run services like databases, like API, RESTful APIs, or whatever the user needs to help its batch job to run. Like, we are really seeing services with Singularity to run small databases to support a batch job in a cluster. It's designed for performance, so we don't have a root own daemon or whatever manager inside the host. So Singularity is a binary that is jumping into the process pool. On that, we are not losing time talking with a daemon. So Singularity can give you almost native performance when running your application inside a container. And it's really secure. One of the design principles of Singularity is giving back the system admin all the control of the HPC infrastructure, rather than the other container root times that they are giving the power back to the developers and the user. Singularity is thinking all the time in the system admin and how to give that system admin back the power of all the HPC infrastructure. So I'm here to talk about an update. So for the ones not familiar with Singularity, those 3 slides kind of bring you into the table. And I'm here to talk about 3.0 release and the major rewrite that we did and the new features that are coming, that are right now in the upstream of Singularity. So Singularity before 3.0, we call it 2.x versions, was a monster around, that was Bash, Python, C, calling each other in really complicated ways. And now it is a Golang project. And one of the main reasons for doing this is that we can integrate with the OCI and the Linux Foundation tools and libraries that they have developed to run containers. And this Go programming language is a compiled language. You can see it as a C++ without the object-oriented programming. So it's a compiled language, really close to C, and it's really easy to maintain. What are we winning with doing this? It is a language really, what I really like from Go is that new users can jump really fast and start contributing to Singularity. So this would give Singularity a bigger and healthier open source communities because everyone can just go and jump and start contributing. The concurrency model of Go really, as a developer, gives you a way of managing threads and developing threads inside the code really fast. As I said, the integration with other container projects, this is why I say that you can start running any OCI compliant image with Singularity out of the box. Because just by calling the Linux Foundation libraries and packages, we are turning those images into the Singularity support images and running it for you. Singularity is also now supporting the cloud native container networking interface, also backed by the Linux Foundation. So you can now do port mapping with Singularity. So you can start your database, your web server with Singularity, and start doing port mapping inside the host, which is pretty cool for people thinking about the NVIDIA example of running graphical jobs through a Slurm, because with the port mapping, you can start doing that. Go doesn't allow you to code the namespaces on the kernel as we want to. So Go also gives you a tool called CGO, on which you can have a small chunks of C code inside the Go code to do what you want to do on C because you don't want to do it in Go. So we are using the CGO interface for forking certain system calls that are really needed for running Singularity. We are following all the Go standards, so Singularity is now a Go-based project. And as I said to the OpenHPC speaker, right now Singularity has its own vendor folder in the GitHub repo. So it is super easy to install Singularity right now. It's a git clone, make install without dealing with Python dependencies, without dealing with any external dependencies. We have our vendor folder in our GitHub repo, and just git clone, make install. You don't have to start calling external dependencies. We have them stored for you, thanks to the Go standards, that you can store your self-dependencies in your repo. But Singularity still is a very complex project, and one of our developers was not happy on how auto tools were managing the way that we were handling CGO, because for doing CGO, you still need to do some .h libraries in C. So we developed a tool called Makeit that is allowing users to build RPMs, and is under work the dep packaging. And this Makeit is really nice because it is going to check for all the dependencies for the C libraries in the host, which are pretty basic, and building and compiling Singularity for you. So when you go into the GitHub repo, you will see that in the instructions, there is no auto config step like we are used to in the HPC realm, but we are using our self-developed Makeit tool. Go versus Python. Other reasons for moving was the large ecosystem of packages, not just the Linux Foundation packages, but the network tools. And right now, Singularity 3.0 can also run C groups. So you can isolate your container processes with C groups with Singularity out of the box. Go test. I've been hearing that testing HPC packages is really hard, and Go test is making life for us really easy to test Singularity for every release. So Go has its own tool for testing Go developed packages and gives you a really verbose output of everything inside that code and what is breaking and what is working. As I said, I always try to bring new open source contributors. It's really easy to be productive in Go. So a user can develop a new feature in a week, 2 weeks, test it in another week, and take that feature into the upstream maybe in a month. So it's really easy to develop new features in Go. For those, that was another decision for moving to Go Singularity. Another big change in Singularity is our image format. So back in the 2.x version, we were using ext3 file system or SquashFS file systems. Now we develop a Singularity image format, which is, as I was explaining, from a high level, you can see it as a tar file, but optimized for container usage. So this is a binary file that we carry some headers that users can leverage to store JSON configs, YAML configs, different labels and environments that they want to when they are going to run that container, so they don't have to hard code those labels, environments, or metadata inside the container, but they are going to do it in the file format of Singularity, which really gives the user the ability to leave the file system, which is this big block, to be just the file system with the application, and all the metadata and how to run that container is going to live in those headers. We are also working, it is not in 3.0 now, but it's going to be in 3.2 maybe, not 3.1, writable overlay. So user will be this file system, this file format is non-writable. So as soon as you build your image in this Singularity image file format, it is going to be read-only. We are working towards allowing users to attach a writable overlay to that same Singularity image format, but it's not yet there. It's been really tricky. What this Singularity image format is giving to us is it is guaranteed to be reproducible, because once the container is built, it is going to be read-only. So if someone tries to modify something inside the container, it is going to break it. It is really easy to archive, because the file system that is inside, it is going to be a SquashFS. So a Ubuntu image is something around 24 megabytes. It's really light. So by being small, it's also mobile. It is control compliant with another feature that is coming in the 3.0, hopefully it's here, that is the Keystore Service. So I'm going to start here, because it's one of the most important things coming in 3.0 is you can sign and verify that SIF image that I was showing with PGP keys and store those keys in the Sylabs cloud service. So you can build your container, sign it, leave it with the key, push that key to our cloud system, share that image with a peer reviewer or a friend or something, and review that that image is still the same image with your PGP key, and pull that PGP key from the Singularity cloud service and verify that image. So one of the new features coming in the 3.0 is the Keystore Service and handling PGP keys through the Singularity CLI. So you can create your PGP keys, store your PGP keys, list them, use them to sign and verify containers, and push them and pull them from the cloud service. Other user requested feature coming into Singularity 3.0 is the remote builder. So we are aware that some HPC infrastructures and also some universities or companies, even in the laptop, they don't allow sudo to the users, right? So they give users a laptop already with sudo block. So users were asking how to build an image if I cannot be sudo at all, even in my laptop. So now in the Sylabs cloud service, the user can just drag and drop the Singularity definition file, the recipe as some people call it, but we call it definition file. And we are going to build that container for you. We are going to spin some cloud services, build that image, and ship it back to you. And we are going to store that image in the container library. You can choose to remove it or not. It's up to you. But once you build your image, it is going to be stored in the library. So let me... So this is how it looks, Singularity. So you have the three tools here, the library, the builder, and the Keystore. So once you build your image, it is going to be stored like this. Well, this is a default, but it is going to be stored with your username, and here is going to say remote build. So every remote build that you are going to run is going to be stored in the library with a unique ID. You can then remove it if you want, but we are storing because we are also giving the additional feature that you can remote build an image, but you can say to Singularity, but don't give it to me. Leave it there, store it. I'm going to use it after this. So those three cloud features are now usable through the 3.0 version in the upstream. You just need to go into our container library and log here. You can log with your Microsoft account, your Google account, your GitHub account, or your GitLab account. So once you create your account, you can start pulling and pushing containers in the library, signing your containers with your stored keys in the Keystore, and also building containers remotely without the need of sudo in your laptop. So this is how the kind of blurry. Yeah, this, let me, if here it looks better. Yeah, it looks better here. Don't trust in the Wi-Fi. So this is how the remote builder looks. We are warning users it's in an alpha review right now, trying to make it more secure until we can say that it's a GA product. And you just drag and drop your definition file here, or you can click and click until you find it in your host, or write it here. So this is a writable box. And after that, you are going to click build, and it is going to be built here. So you can see, I'm still locked. You can see like, and we are going to show you live output of how are we building that image for you. So this is my user. So here will be my user, which is Sylabs ed /builder / a unique ID. So that's the unique ID on which the image is going to be stored. And this was built via CLI. And after that, we can see the image in the library. So this is the library of this user, remote builds, the unique ID, and the image. And this is how the image looks like in the library. And all this, I'm showing you through the website, but all this can happen through the CLI, and we always show the example here. So this is how you can pull this image with the name or the image with the SHA. So why the SHA? Because this library was thinked and designed for data users. Let's say bioinformatics. So if you're building the same image over and over again, maybe with the same name, at some point you will want to go back and check via the SHA sum of the image and see where something fell, or let's say your bioinformatics data was changing through time, but you forgot to change the image name. So you can go back and check them by the SHA sum. So I can do the same build over and over again, and this is going to change the chasm because it's always going to be unique. Let me show you. Here, so this is how the key service looks like. Here you can see that I have 2 keys stored. So once I created the keys in my host and I use them to sign my containers, I push them to the key store. So let's say I change my laptop, or I'm going to give an image made by me to a user and say, oh, okay, you need to verify that that image was made by me, and you are not pulling a container that is not mine but with the same name. You can then pull these keys in another host and verify an image. So this is kind of a key hub. You can start pulling keys to verify your containers. This is how you can create, list, and push keys in your host. So as I'm saying, all that I'm showing here with the web UI, you can do it through a CLI. So UI people, CLI people, trying to satisfy all flavors. Other feature coming into 3.0 is the network virtualization. As I was saying, by leveraging the Linux Foundation packages in Go, users can now run all these features of those are network features with Singularity, making it better and easier to run services like web servers, like Apache, like Spark, and all those scientific RStudio, and do it port mapping, or creating new networks, or I don't know. Users know how to really complicate themselves using this tool, but it's really cool that you can do a DNS to a service that you're running through Singularity, or do a port mapping with Singularity. So network virtualization is also a new feature coming into the 3.0 version of Singularity. Security. As I was saying, we are always thinking on how to give more power to the system admin. We are always thinking on how to make the system admin the master, the owner of the system, and not the users. So these are tools that the system admin can enable via flags or via the Singularity config file to make more secure or to remove capabilities for the users. So the system admin can decide to drop capabilities or to give users more capabilities because they are trusted users. But these are system admin features. Also, Singularity 3.0 gives C groups to users. So you can now run encapsulated processes. You can limit the memory. You can limit the I/O. You can limit devices that the container will be able to see. You can limit the number of CPUs. All the things that you can do with C groups, you can now run it out of the box with Singularity 3.0. This, of course, requires elevated privileges. So this is up to the system admin how to give C groups to the users. This is how the sign and verify that I've been talking here looks in the CLI. So when you run sign without any flag, you can choose from your key list the key that you want, but you're going to have one by default. If you don't use any flag, it is going to use the default. It is going to sign the image, and when you run verify, it is going to tell you, okay, this image was signed by the PGP key ... by the user . And you can also delete keys in the system with new tools, not Singularity, like remove. I want to show here. So this is the output of a Singularity sign, and as I'm telling, it is going to sign in with a default key. When you have no keys on the system, it is going to create a key for you from the Singularity CLI, so you don't have to go to your PGP key application in the host. Singularity is going to call that PGP application in the host and create a key for you. This is how the Singularity push looks. Singularity 2.x just had the pull, so you could pull from the Singularity hub, which is hosted by Stanford, but now you can also push to a container registry. So back in 2.x, you could just pull, but we are now giving the users how to save their images in a cloud-based system. So pull, as 2.x users already know, and this is how verify looks like. So it is going to tell the user the email of the user in the key ID of that user. Another feature that is coming with the signing and verifying that I don't have demo here because it just got into the upstream is that the system admin, but I can show it. The system admin, by modifying this file, when you install Singularity, I had installed in user local, the ECO.toml, so the user admin can tell to Singularity, you are not going to run any image without verifying that they have this key or this list of keys. So one workflow that we are seeing, like in universities, is the project manager of XYG research project has to give his sign-in to the image, and maybe the QA or the system admin team will verify that image before running the image in production. So the system admin can tell Singularity, you cannot run any image without at least two keys, or at least this key, and the system admin can tell Singularity which key. So don't run this image without verifying that it has this key. So here you can see a list of of keys or just one key, and you can tag them by white list or black list. So you can say all images with this key can run, or the other, you are betting a user like a bad student that was doing crypto mining, but he was telling the system admin that he was doing his research thesis. So you can blacklist that user's key and say, okay, whenever this key is going to run, blacklist it. So we are giving the system admin whitelist and blacklist for the keys. And trust me, before joining Sylabs, I was a system admin at my university, and I had a student running crypto mining. And when he signed for using the HPC infrastructure, he said, no, this is my research thesis. Well, here is well, I have all in screenshots because someone told me do not trust in the Wi-Fi. This is how you run a Singularity build. So now in 3.0, you can build images from registries, not just from definition files. So in 2.x, you could pull from registries, but now you can also build from registries without privileges. So you can see that there is no sudo here. We are also only asking for sudo privileges when trying to build from recipes, from from definition files. And you can show into a user registry define without sudo privileges also. So right now, as I was saying with the OCI compliance, you can show into any OCI or Singularity Hub or Sylabs library without sudo privileges, and you can just start running your container out of the box, and you don't have to build it locally. So this Docker Ubuntu latest is not on host, and I'm telling Singularity to show into it. So Singularity is going to really download that Ubuntu image from Docker and give you an interactive show into it. Here is the example of how to use GPUs. So just by calling --mb, Singularity will map all the GPU libraries on the host and expose them to the binaries inside the container. So what Docker and the OCI people are really doing with NVIDIA is that they are building and compiling the NVIDIA tools inside the image. What we are giving to the users and to the system admins is the problem is that they are going to be able to use the same libraries on the host, which is more performant than compiling, let's say, in a workstation and trying to run those GPU compile libraries in a HPC infrastructure. You're going to maybe have different libraries, different performance. So with the --mb, Singularity is communicating with the NVIDIA tools in the host, the NVIDIA SMI tools, and asking for the libraries in that host and mapping those inside the container. So you can see here a TensorFlow example, which I'm not going to run. TensorFlow is something like 5 gigs image. And just with the --mb, we are exposing the host GPU libraries to all the binaries inside that image. When releasing the Singularity 3.0 last year, thanks to the users, we won 3 HPC Wire editors and users award, because we won the users rated awards and the editors rated awards. So it was 3 awards last year at supercomputing, and this is a small bit of all the users already using Singularity from 2.5 to upper versions. We haven't seen users like professionally or in production using 3.0, but we are now inviting users to start doing a Git clone from the upstream master and really giving a try to 3.0 so they can have access to all these features. Another slide, we are hiring, so if you are interested in change and working in Go and learning about Cisco's kernel file system, signing with PGP keys, please give me a call. And I'm open to questions. This was a quick update on what's new in 3.0.
Any questions for Eduardo?
And sorry for my voice. The snow. Kenneth told me that it was going to be warm, and so I'm kind of cold.
So I have a question related to the remote builder. Do you have something similar to that so that we can also do the build on premises, so that people that don't have root access on the system could do something similar without transferring all the containers outside, because we have large containers, so that could be
Oh, you
useful.
mean like installing the remote builder service in
something like that? Yeah.
Whoa, this is extreme. The plans for remote builder on-prem, I'm something around the 3rd quarter of this year. It is on plans. It is hard because we need to develop compatibility with a lot of virtual machine drivers, depending on the drivers that you're going to have in your infrastructure, right? So if you have KVM, QEMU, or VMware, so we need to develop all the options So we can say to tell the users, okay, you can install it on-prem, because the build itself is happening inside a VM, so the system admin won't worry about the user doing something really weird during that short time on which he has sudo access. So that's like the most tricky thing, like really working with all the VM virtual machine drivers in third quarter of this year. But this is streamed, so
I just wanted to know if it's on the roadmap.
oh, it's on the roadmap, but we are working on that.
More questions?
Would it make sense to have a --MPI option, just like the --NV option you have about the NVIDIA libraries?
MPI?
Yeah, to have the MPI libraries installed and optimized for the host available in the inside the image.
What? That would be a really interesting use case, because what we really propose with MPI and Singularity is calling Singularity through MPI. So you do MPI run Singularity. So MPI will handle and manage the jobs. So there's no need of mapping MPI libraries inside the container. MPI is going to be running the job.
Yeah, but when you do that, you don't. I've had issues with MPI software inside Singularity that need to talk with a Slum manager, and so I was not sure how to handle this. But don't you need to install the MPI libraries?
Yeah, you also need to install MPI libraries
inside the container. So sometimes you end up with an MPI library inside this container, which is different from the MPI library installed on the hardware, and there can be friction. So that's the reason why I was thinking about moving it through the.
Can I, like, I'm also.
It's a very good suggestion.
I'm taking notes on that suggestion. Yeah.
It's the same idea for like you have for NVIDIA, but for MPI. And the same motivation. Yeah, you need stuff in the container and outside, and they need to talk to each other, so they need to be in sync. So it makes sense. It's probably not as simple as it is for the GPUs, though, because there's more.
Yeah,
than one
because with the
API.
GPUs, thanks to NVIDIA, they have this small binary that you knock, and it just gives you all the links and all the sim links that you need for running NVIDIA. With MPI, it would be a bit more.
I think it's even a bit more complicated for MPI. As far as I know, for OpenMPI, that's actually split in two parts. A part which is linked in the application and should, I think, be in the container then. And then a part that's outside. And before, those versions needed to match, but in recent versions, I believe there can be, within reason, some differences in versions between the backend libraries and the front-end libraries. So it's MPI in containers is really tricky and complicated. Yeah, I think it's very difficult to implement the --MPI because there's so many MPI implementations, and depending on the version, you would even need to do different things.
Yeah, that discussion is going back and forward in the GitHub issues. But right now, the recommendations that we give is this example, and at the end, run it through MPI. But you are right, can be some friction if the container has some different libraries.
If in this case, if OpenMPI 2.1 is not installed on the hardware, it does not work. So you need to have the very strong mapping between inside and outside the container. So the idea would to be able to get rid of this tight link, because the thing is, when you build an image that works on one cluster, you want to move it to another cluster, it has to have the same slurm and the same MPI installed, and then it breaks the portability of the containers.
Maybe one idea can be to try and convince one of the MPI libraries to help you out with this. And as soon as one does
Or
it,
not help me
the
out,
others won't.
but this was proposed in a BOF in the last supercomputing, on which users told the MPI developers, you need to really make a standard for the MPI APA.
But that exists already.
But
the Impeach has a standard already, right? That Cray, Intel, and Impeach itself, they follow it, right? OpenPI, yeah, OpenPI has a different standard. Right,
Is
so
defining on the same standard. Is that's the user code that was made in the BOF. Like, if we had a standard API for MPI, it would be really easy to develop things like dash MPI for Singularity, or maybe for other tools working with API easier, because you can be moving from MPISH to OpenMPI to create MPI and whatever, if the API was as the single API for MPI.
That's not happening. I don't think that's happening. And what you could do is just work together with one of the current standards, get it to work, and the other ones will jump in and do whatever they need to do to get it to work.
Yeah, but the discussion about a standard API was made in last supercomputing.
Yeah. Okay.
Because not just Singularity developers, but other tool developers are really struggling working for all the MPIs out there. Like, if you define just one API that I can develop on, I'm going to be all MPI compatible. So this discussion was bring.
Other questions? I have another one. You mentioned that you're not seeing any strong adoption of Singularity 3 right now. In the user base,
In
why?
the user base, yes. In the system admin base, no. So the issues and the bugs are being found by users in their workstations.
Okay.
But I'm confident that 3.0 is now ready to be installed in production systems and users to start testing it.
Do you think the switch to Go has something to do with that? Like, lots of sysadmins not knowing any Go at all, so they have to figure out how to build Singularity themselves, and it takes time to figure it out, and they don't have time to.
Oh, installing Go is just downloading a binary.
Yeah.
You don't need an RPM or anything.
Okay.
Or you can just grab the Singularity RPM and it is going to do everything for you.
Any other questions? No. Okay. Thank you very much, Eduardo.